I'm here today as Dr. Elizabeth Cook, your grid modernization expert, where, I have found a passion of really connecting with the industry and informing and sharing really the operational and technology challenges and really hurdles that really can be great opportunity for us in this industry to show up and transform the grid as we need it to be with all of the new available resources and capabilities that we've been developing really over the last 100 years. But as we know, we are on a tipping point from where the creation of the grid to where we are now. So with that, I'm going to jump right in and kind of go back through a reminder. And for those of you that are joining me here the first time on this lecture, I also have a podcast called the Grid Mod Pod, where I have these discussions with industry experts. And I've also have a few other curriculum that I just create to help share and provide the information, not only to those within the utility, but to all of the external stakeholders that have an opportunity to help partner and create the momentum around innovation and creating the dialogue as well as the action to make the changes that we all see coming. So just a reminder where we started. We once had a world where there was not light at night or manufactured by man. We all sat in the dark, and when the sun rose, our day started, and the sun set is when we started going into our night. And it wasn't until 140 years ago that the reality that we have today was developed with the minds that we all carry in to our present day. We've created the way to create a flow of electrons that really lit up our lives. And from that phenomena, which I won't get into in this lecture, we created a grid that started to more or less gain the ability to create a massive amount of electron flow. And so we built bulk generation stations far from the load centers, aka where the large population centers were. And we put it up onto high voltage, which then was able to traverse the electron flow at a great pressure at high speed, which then dropped into a distribution system, which is a lower voltage, lower pressure, lower speed, and then ultimately into the homes and buildings and really all of our commercial industrial entities that use this new energy source to power our lives. And so to be able to do that, we also had to have the ability to communicate from point A to point B. So at the same time that the electrical grid was being designed and built out, we also had the ability to communicate. And so I think there's a key indicator here in this world that we are in at this point in time is the power of communication, not only from a technology perspective, but also from the communication of person to person. The substations themselves would not operate unless there was a manual intervention. So we went from an ability to design the grid to flow the electrons with a large amount of manual intervention, which was then shared across telephones at the time and ultimately came to where we are today. But again, that was a pivotal moment. Another benefit of the grid at the time of the creation and the ultimate design that we have today is that the customer, aka the person that was using the energy source, was very predictable. We actually created the grid for the need during the Industrial Revolution, where we wanted to continue the creation of stuff during nighttime. Very simplified. But another big indicator was the customers, the people, were very predictable in respect to the idea that we all wake up, we all head off to work, we all come home from work, and then we go to bed. So the way that the load curve or the response of how the system was to perform, because at the time and still today, there was no large ability to store energy. The exact amount of energy that is generated must be consumed. So the full design of the electrical power grid is based on that phenomenon. And because the customers, the people, were very predictable, we were able to build and design with that known factor. And I say this with stress because when we think about where we are today, we have now started to see, not maybe everywhere across the various geographical footprints and utility territories based on, what is available to the customer, but there has been many use cases really over the last 20 years that we now have the ability for the customer to become less predictable. And that is with the new technologies that we'll talk a little bit more through this lecture, is there's a opportunity for the customer to not only use the energy, but generate at the point of distinction of the utility and the customer. So we've created a two-way power flow. And we've been talking about this phenomena now for over 20 years, but at this point in time, the tipping point is how can we now take a grid that was ultimately designed for this one-way power flow, which there is a large amount of change that has happened over the last 100 years, but that phenomena in itself, the ability to dispatch, generation, and consume at the same time still holds true. However, with the ever-evolving new technologies, this capability is starting to come into question and AEIC becomes variable. Also, something that has happened over the last 100 years is the way we communicate. So we went from landline systems to now we have Wi-Fi. We have the ability to communicate not only from person to person, but from device to device. So at a time when the grid was first designed, there was manual intervention, and now we have millions of connected devices that can literally talk to each other and make mathematical calculations and then ultimate decisions to take action. This in itself has been growing over the last 30, 40 years. So we are in this position today where we are starting to see the proliferation. And what I would love to do is take us on a journey and a discussion of what does that really mean to the folk that work within the utility and that are responsible for the safety, reliability, affordability, which is a huge proponent of where we are in regards to where we're headed, as well as the sustainability of the ultimate use of the energy that we now hold true to our heart and is the lifeline of society. So taking us into where we need to be. The devices, as I just said, used to be operated with manual intervention. We got to a place where the devices can actually operate by communicating to each other through Wi-Fi. And at the same time, we have all the technologies where the customer now can be engaged and understand how their energy use can ultimately impact the larger grid. With that, you're going to go from a space where the devices are in the millions, and we're going to go to an area where a utility could potentially be observing and making decisions, aka the grid that they own, exponentially growing the demand of the need for communication and the strength of that communication. Also, we're going to a space where the customer will have many opportunities, not just how we use energy at this time and we do not use, but there could be the enablement of a individual customer to make decisions on the behalf of not only themselves in regards to using less energy or when they use energy, but that decision could also play into their community and then ultimately the overall system. So with that behavioral awareness, we can now have a new variable to change and adapt to. Once again, going from a grid that was one way, very manually operated, to now an area where the decisions of the customers could have an impact on the overall full operation of bulk generation, transmission, distribution, and then the edge. For those of you that may be listening and wanting to understand how can I, an individual, help support this transformation, as well as those that are sitting within the utility, what actually is different from the knowledge or the information that we used to have to where we have, considering the fact that we do operate the grid 24/7, 365. So a big change of what's occurring is the grid visibility. One thing to know is the challenge for the industry as a whole. This has been rapidly changing. So at a time when the grid was first designed, the awareness was not required to operate the grid after the electrons left the substation and was distributed across the distribution. And the reason for that is with the one-way power flow, the engineers could calculate based on the wire size and the number of homes that were connected and then plan for the distribution of those electrons for many years to come. The visibility of the grid to the engineers is now becoming very important. And so what the industry has deemed the edge of the grid, aka the customer and behind the meter, as well as the devices from the substation to the customer. But the edge is less visible. We need to make it more visible. And with that, we can then help support the behavioral changes as well as the dynamic flow that now is occurring on the grid. One thing that happened was the meters, which I think there's a little fun fact. One of the first discussion points that was taking place in the turn of the century was, as the grid was being built, how was the utilities, or the folks that owned the assets, going to be paid? And so there was a discussion, do we create a contract and the customer will agree to turn off the power when they say they would, or should we design a device that can take in the information and report back the usage of energy, aka the meter is what we now know. And so the meter was an asset to the grid owners only as an opportunity to quantify the amount of energy being used. And it wasn't until 25 years ago where we started to see the powers of computers and computational power is if we had more of the metering data, we could then start to see the health or the visibility of the edge of the grid. So there was the smart meter discussion that really started to come out around 2009. And then now here we are in 2024. These meters have the potential to change how the not only utility, but external stakeholders and customers can start to transform the grid to be the grid that we need it to be. And so the edge is where the customer's opportunity to interject and communicate with the utility asset owners. So it's a very powerful device now. However, that device in itself is in a moment of transformation as well. And I only share the perspective of the metering because it will come up quite often in some of my lectures, but the key to it is when we first deployed these meters, the data point we wanted was the usage, was the watts, the consumption. But now with understanding that the customer's voltage, current, and watts all being provided in almost near real time could help support the overall operation of not only the distribution grid, but as this proliferation occurs, it will impact the ultimate needs of the transmission and the bulk generation. And that in itself is quite powerful and something that we should remain focused on, where the transmission distribution are not separate. They are now should be seen as one, as well as the bulk generation and the customer. So instead of operating each in a silo, all groups should understand the power that each has on each other. And that is a new conversation that needs to be brought into some of the decision-making and ultimate realities of where we go. Stepping into really summarizing a lot of these disruptions that I have kind of been alluding to, but bringing it all together here. So the first set is really something that we have deemed and named distributed energy resources. And this is important. One thing I've learned in my journey of 20 years of working with electric utility space is the language or the words that we use to describe or quantify an idea, a philosophy, approach, a technology is very powerful. And it's also an essence of why I want to show up and communicate and educate. If we all can agree and understand why the words that we're using mean what we're saying, there could be a lot more opportunity to make progress more rapidly. For an example, the idea of distributed energy resources to most folk, even within the utility, as well as those outside, think solar. But they don't realize that the idea is energy sources that can become plentiful. Not only solar, but energy storage, or smart devices that can enable a customer to take over or understand their behavior, aka smart thermostats, smart water heaters, etc., as well as the idea that customers or large businesses could develop microgrids of their own, where they then could have full awareness of how their operations can be self-contained. So the terms solar, smart thermostats, smart heaters, battery energy storage, microgrids, and the all prevailing one is electric vehicle charging, but we're gonna give that one of its own disruptions. So that's DER, and that in itself is transforming. The other area that we have to be aware of and understand the transformation and really not only that they exist, but that these disruptions create great opportunity for the synergistic conversation that we must have. Is the utilities in themselves are transforming in respect to what IT is, the digital utility. The ability to do the job that they have been doing, but doing it with cloud services, doing it with massive amounts of more data that creates an increased visibility that was never available prior. So with this new data and the massive amount of analytics and just the idea of big data in general, which I also have to say, we could have a whole lecture on the importance of the words data analytics, artificial intelligence, cloud services. What do those mean to the overall safety and security of the grid? But those are all disruptions, and also great opportunity to capitalize on these opportunities that are presented to ourselves. The third is electric vehicles. And so, as I said, this in itself is a DER, or could be seen, but instead of injecting, it's predominantly an additional load, aka additional use of the grid. And so the key point about transportation electrification and everything happening in this space is the utility as we know it, aka the business models, the incentives, and the regulatory matters, have been developed and seen really with the only last 40 to 50 years, where the grid itself started to think about using less energy. So the models, the thought process, the analytics was taking into account load growth being minimal, if not decreasing. So what has happened in the last 5 years was this rapid state of no load growth to exponential growth. And so transportation electrification is not only changing the load growth, but there also is an opportunity to vehicle to grid, which the batteries of the actual vehicles and or the charging infrastructure can not only take electrons off the grid, there's technology coming to be where it can push electrons on the grid if there are signals to ask for it. The next disruption is the revolution of energy efficiency. So what energy efficiency itself kind of peaked its head in the 1980s and 90s, where the trajectory of us as beings using energy was ever growing, as I just mentioned. However, there was this state where we're all like, we need to use less energy if we're going to be able to keep up with this energy demand. There now is a very large focus on driving energy efficiency programs to empower the customer and also the utility to really, at this point in time, offset the large growth that's occurring with transportation electrification. But a catch-22 with the ability of energy efficiency has also shown that the heat sources, the ways we heat our homes and or cool our homes through heat pumps, the technology and the capability has become much more efficient, which is also driving the use of the energy source, aka changing from a gas to an electrification resource, not only because it's efficient, is now becoming a viable option, which is load growth. So that in itself is a large disruption to the overall energy system. And the last but not least is us as beings. I think everyone here can understand that there has been a transformation of how we show up day to day, not only with ourselves, but each other, but also having access to all of this digital information at the fingertips, aka our smartphones. So with those smartphones have unlocked this awareness and desire to have information immediately and quickly. There is a new lifestyle that our customers, our beings, really expect from the utilities. And that in itself is a disruption. Not only how we want to receive the data, but how that data is shared, how the information is shared, and then what we can do with it, not only just in how we use energy, but really in all aspects of our life, such as ordering groceries, the Uber technology, those ideas that 10 years ago was not even on our minds, but are now becoming a very viable option to our day-to-day decisions. So kind of like thinking that through and going back to the fundamentals of the grid. The traditional grid had bulk generation, transmission, distribution, customer. The direction of those various technologies were one way. The bulk was connected to the transmission. The transmission job was to receive the generation of the electrons and distribute it to the distribution grid. And the job of the distribution grid was to then distribute it into the commercial industrial businesses as well as the residential individual homes. Where we're now headed is each one of those elements are now being changed in regards to how the various devices work. So the bulk generation is still distributing down to the distribution, but the distribution grid now has all of these new technologies, as I mentioned. You have energy storage, you have the ability for solar to become rapidly scaled. There's a lot of innovation going on, not only in solar panels themselves, but where solar can be installed, such as in the windows, in the shingles. I mean, there's a lot more coming out. You have the ability for not only large customers, such as businesses or consumers of large amounts of energy to deploy energy storage, you also have the ability of the customer. Other areas are, because the customer now has the ability to take on the generation of energy, they could then become prosumers, or they could dispatch themselves. So there's this idea of creating a world where there's a third party that can aggregate all of this accumulation of distributed energy resources and distribute it and communicate to the distribution grid. So all that to say, there are multiple resources that are going from a one-way to not only they exist and are brand new, so you have to understand the technical phenomena and how they interact with the grid, but then also they're creating the two-way flow. So to unlock that capability, and I think this is one of the most important statements of this lecture, because I think we all get lost in the silos depending on where you're sitting within the utility and outside the utility in one of those each individual disruptions. And within those disruptions, there's multiple disruptions. But what can unlock and create a comprehensive ability, not only for the utility to take on that position, but also for others to be a part of this solution, is the systems to collect the data, convert the data, and analyze the data. That being the fundamental foundational building block. Those words I just said, collect, convert, and analyze, are very complicated and different. So they create change. And as all humans know, change is something that we don't always enjoy. But with that change, we have to be able to communicate how the change will occur, who will be impacted, who needs the data, how the data needs to be converted, who needs to be able to convert it, and then how and who to analyze. So a big part of this lecture is really kind of understanding the importance of operational excellence and the empowering those that believe that they can be a connected leader, an energized leader, no pun intended. Someone that can grasp the large, big picture and help to drive and inspire and keep your eye on the ball, create the North Star, that if we can continue the conversation and be allowed, especially in our regulatory and financial models that we sit in, to collect the data, convert the data, and analyze the data, then we can create the opportunity to enable those 5 distinct disruptions that I just spoke of, develop solutions to enable those. And so a big part of the who is really understanding how the operations of a grid occurs. There's multiple teams within the utility. You have the folks that are out in the field operating these devices. They have a talent and a capability that's very diverse and different than, say, the folks that sit inside the control room and actually have to observe the computer screens of this new available data and make decisions on how the grid is operated for the safety of the field operations and the reliability and safety of the customer. But also, they have been operating the grid for so many years. Now they have this new technology, new data that really gives them insight they never had before. It's change. But that capability, those skill sets are very different. Then you have your engineers and individual contributors that are in charge of planning the grid. Not only planning the grid really for tomorrow, there's a set of beings that have to do that work, plan all the planned outages, determining, when inspections and maintenance can occur. That's the day ahead planning. You also have individual contributors that are actively looking on the 3, 5, 10-year plan of customers desiring change, aka who's going to install their next charger, who's going to install solar, and then what large companies are going to come into the territory. So you have those set of engineers. Then you have a set of individual contributors that are asked to manage the existing assets. Not only ensure that the ratings, the standards, the specifications of all of these individual pieces of equipment are adequate and can handle not only today's operation, but the next 3, 5, and 10 years. That in itself is a large set of skills and topics of information that is very different than the prior 3 I just said. Then, not to belabor the point, but you have engineers within the utility space that are there to actually design the structures, the conduits, the cable systems, and really all of the different pieces of grid inside of it. And so I could walk through each one, but just being aware of how each individual group currently works today, where they've been, where they are, where they ought to be. That is a very large conversation. But to have the right leaders to drive that. The strategy behind it is you understand the core business. So wherever you sit as a stakeholder, inside the utility, outside the utility, do you understand the core business? Do you know how to ask and receive the correct answers? And while you're doing that, you also need to understand how to grow the core. And at the same time, which is the challenge, scale the new. So that in itself requires a lot of one person. So therefore, it's very powerful to have the right teams in the right rooms, having the right conversations, driving these decisions. Hopefully you've taken some perspective into what's occurring in this transformation within the electric utility space. And the objective of this lecture is to give some founding principles of the basic work the grid does. Understand that there's not just 1 or 2 disruptions, there's 5 large disruptions, and even within those 5, there's multiple. So the grid in itself is being asked to do a lot. And the third, and hopefully you heard it from what I was saying, is there is plenty of opportunity and solutions available if those that are empowered and sitting in a position to help make decisions and drive progress forward is understanding and asking the questions of what is your plan to go from where we were, where we are, to where we ought to be in regards to the data. Collect the data, convert the data, and analyze the data, and then distribute that information into the hands of those that need to make the right decisions. And with that, I look forward to getting to the dirty deets of some of these individual topics in our next episodes.